question is related to light and the polarization of the light. When an incident ray of a light meets a boundary between air and a glass, some of the light is reflected. The reflected light is partially plane polarized. What is meant by the term plane polarized? So the term plane polarized means the light which is having only one component of a vibration, and the direction of the so vibration or oscillation is there in one plane which is perpendicular to direction of wave. Or you can also mention a vibration or oscillation in one direction and perpendicular to direction of the wave. So the light which is having one plane of a vibration and that plane of a vibration perpendicular to or 90° to direction of wave. So we call that as plane polarized light. This is a definition which you have to learn. The second part of the question, deduce whether the refracted ray is unpolarized or partially polarized. So how we can deduce the refracted ray, whether it is partially polarized or unpolarized? So refracted rays because the refracted ray also have a refracted ray is also the plane polarized, because so refracted ray there is less planes are there for oscillation. So refracted ray has a plane polarization perpendicular to the plane of a polarized light, or we can also say the refracted ray must also be partially polarized. So remember, whenever the light strike the surface, as a result, when it strikes the surface, like this light is unpolarized light. Unpolarized light means multiple component of vibration. But when it strikes, so it will be partially polarized, and same thing happen here as well, because the refracted ray is not having too many planes to, as it is enter the region. So refracted ray should also be partially polarized. So whenever the light strike rarer to denser boundary, it will be the reflected ray as well as the refracted ray, both are partially polarized. What is the meaning of partially polarized? Like it will have two components, but most of the components are being removed. If most of the components are removed, we call that as a partially polarized. So answer, deduce whether the refracted ray is unpolarized or partially polarized. So your answer should be partially polarized, because like there is a region, the space which is available for this light to move, that is a limited space or limited plane is available. That's why it will also be partially polarized. Like the particle cannot vibrate, the component of the light cannot vibrate in all the planes as it enters the medium. So that's why it should be partially polarized. So Brewster angle the reflected rays completely plane polarized. This occur when the angle of when the reflected angle and the refracted angle are at right angle to each other. So Brewster angle plus R, Brewster angle plus R is equals to 90. So I mean these two angles, when the sum is equals to 90, the light which is reflected is polarized, plane polarized. Show that the tangent theta B is equals to Ng divided by Na, where the Ng is a refractive index of a glass and Na is refractive index of the air. So we have the formula N1 sine theta 1 equals N2 sine theta 2. So N1 is a refractive index of medium 1, for example, the refractive index of air, and N2 is a refractive index of the glass. So we can say N1 so it will be NA sine theta 1. So this will be theta B is equals to N2 sine. What is N2? N2 is actually equal to the refractive index for glass and sine theta 2. So theta 2 is actually equal to R. So N1 sine theta 1 is equals to N2 sine theta 2. And what about the value of the R? They mention here that this R, because theta B plus R is equals to 90, so R is equals to 90 minus theta. And remember a trigonometric ratio that if we have a sine 90 minus theta, like if it is sine, this is theta BR, so sine 90 minus theta is equals to tangent theta. That is the trigonometric relation. So sine 90 minus theta is equals to tangent theta. So in place of R, we have theta B plus R is equals to 90. So R is equals to 90 minus theta B. So NA sine theta B sine 90 minus theta is equals to cosine theta. So because relation is there, because the value of like if I say we have sine 90 minus 30. So sine 90 minus 30 is sine 60. So value of a sine 60 will be same as cosine or a cos 30. So same thing here, sine 90 minus theta is equals to cosine theta. So this will be ng and then sine, this will be 90 minus theta b, because r is equals to 90 minus theta b. So and sine 90 minus theta b is equals to cos theta b, and when we simplify, cosine theta will go there in division and n will, so n sine is equals to the sine theta b divided by cosine or cos theta b is equals to ng divided by na. Sine theta b divided by cosine theta b is tangent theta b. So tangent theta b is equals to ng divided by na. So this second part is actually related to what we have derived the formula. We derived the formula that tangent theta b is equals to refractive index of glass divided by refractive index of air. So theta b is equals to tan inverse refractive index of glass, that is given in the question 1.5, and refractive index of the air is given 1. So we'll get theta b, which is about 56 degrees. Then different colors of visible light as reflected as they passes through a prism as shown. A student suggests that the Brewster angle of a violet would be smaller than of red, and violet is refracted more than red, as you can see. Criticize this suggestion, like whether this suggestion is right or wrong. We have to criticize. So here, because the light which bend more, the refractive index will be higher for that. So we have student suggested that the Brewster angle for violet light should be smaller. So we already calculated this. See, we have the relation that tangent theta b is equals to refractive index of a glass divided by refractive index of air. The refractive index of a glass changes with the type of a light we are using, because violet bends the most. So for a violet light, the refractive index is more. If refractive index is more, what will happen to this value of theta b? That will also increase. So it means the Brewster angle will be higher for a violet, and if we have a red light, because red bends the least, if red bends the least, it means the refractive index for a glass for red light, it will be smaller, so the Brewster angle will be smaller for red. But student suggested that violet will have a smaller Brewster angle. So student statement is not correct, or suggestion is not correct, because when refractive index increases, the Brewster angle will also increase. And violet will have greater refractive index of appear for violet, it appear greater refractive index because its speed changes more than red, or it bends more than red.